Hello friends, we are going to start with the second part of the topic which we had discussed in the last session, that is taming inverse response. As we had seen in the last session, response is said to be inverse if the expected response, as you can see in this figure, the expected response was along this curve, but somehow we found that the actual response, it first went down and then it went up, and on close observation we found that it happens because you see over here there is another process which is moving in the opposite direction. So as these two processes they add up, rather they get subtracted because they are in opposite direction, so ultimately they get subtracted to come to this point where you get an overall response where it first goes down and then starts moving up. So this kind of response we had seen in the last session. It is called inverse response, and since this response is quite unpredictable to most of the people in the beginning, the controller was expecting that it should be getting something like this, but what it ends up is you get something which is first going down, so the controller it gets confused and that can create lot of problem. We had also seen that in all these kind of responses which are categorized as inverse responses, there is one thing which is very peculiar to all these, and that is that mathematically speaking, if you take the transfer function of these kind of responses, you find that the zeros of the transfer function they are always positive. It means that in case the process is having a zero or more than one zeros which are positive, then the process is likely to exhibit some sort of inverse response. And the way to tame this response, the way to overcome this response is that somehow if we are able to shift the zeros from the positive domain to the negative domain, we make the zeros negative. In that case, this inverse response automatically gets tamed. As we see that here you have a process which is again an inverse response exhibiting process, and you can see over here that here you have something which is having one process and there is another process over here. The two are getting subtracted because they are moving in the opposite direction, and what you get over here is the output y. But then there is something special about it. In this case, we have a condition, and the condition is, as you can see, this is the condition that this tau 1 upon tau 2 should be greater than k1 upon k2 should be greater than 1, and you can very well see that these are this tau 1 and k1 and tau 2 and k2 are the ones which we have taken from here, and these two uh, processes are having well-known characteristics. Their time constants are known, their sensitivities, their gains are known. So all these, once we see this condition is fulfilled, then the open loop response for this kind of process will be given by, as you can see in the figure also, this is given by this y is taken from here. This y is nothing but whatsoever is the step change which you're giving over here, ysp, it's getting multiplied by gc, it's getting multiplied by this block, and you subtract from it this block. And once you do this little bit of mathematics using your own copy or pencil or pen, you will find that this y bar, which is the open loop response, it is given by this equation. And further, if you examine, you find that the zeros of this equation, the zeros which are obtained by you're equating this entire numerator equal to 0. This 0 comes out to be minus k1 minus k2 upon this term over here, and with this condition that tau 1 upon tau 2 should be greater than k1 upon k2 should be greater than 1. Once this condition is implied over here, you find that this 0 comes out to be positive, and the positive 0 means we have inverse response which needs to be tamed. Let us have a look at this figure again, and we will add one compensator to it. As you can see over here that we have, along with this the initial process which we had seen in the previous figure, we have this additional block, and this additional block is known as compensator, and this is going to compensate for the positive zeros which you are getting, and on account of that we will be able to see that the inverse response is tamed, and this compensator has this value k which we will compute a little while later, but otherwise it's having this block 1 upon tau 2 s plus 1 which is taken from here, and this block 1 upon tau 1 s plus 1 which is taken from here. So if tau 1 and tau 2 are known to us, this compensator block can easily be designed. We need not bother about k1 and k2. This k is something different, but right now this k will not be affected as such by k1 and k2. Once there is a condition which we will be seeing, that condition is fulfilled, then we will be able to compute this k. Now this particular thing which we call it as a compensator over here needs to be designed to tame this inverse response. We see over here that the output of this compensator is given by y dash s, and this y dash s is nothing but you take the change in set point multiplied by gc and you multiply by this compensator. This is the set point change, this is gc, and you have the compensator over here. Output of this will be given by y dash. And if you recall what was y, the open loop response of the process without compensator, this y was given by this formula over here which we had taken in the previous slide. And what is happening over here at this point, you can see that this y and y dash, these two are getting added, and these two get added to get into what we call it as y star. So ultimately the feedback which is coming to the process is y plus y dash, and that comes out to be equal to y star, and we have to see what this y star is actually equal to. So what we are going to find is y star as equal to y plus y dash. Star, once we add it, it comes out to be as given by this equation. And there is something very interesting in this equation. It is that the zero of this equation comes out to be as if we put this entire numerator is equal to 0, and then whatsoever is the value of s, we will call it as 0, and this 0 comes out to be equal to k1 minus k2 upon k1 tau 1 minus k2 tau 2 plus small k into tau 1 minus tau 2. And we are now more interested in this small k, because depending upon the value of this small k, we will see what value of 0 we come to. And this k can be designed if we somehow are able to put the value of k which is at least equal to, but preferably it is greater than the value given by as in this diagram over here. In this figure, this k2 tau 1 minus k1 tau 2 upon tau 1 minus tau 2, this value, you equate this value and take k to be, let us say, 5 times this or 10 times this, to taking the value of k. And if you put this value of k over here, then you will find that this zero, if you examine, this will always be negative. So this I keep it to you. You take your pencils and copies and you examine by putting the value of k whether this 0 actually comes out to be negative or not. And once we say that this 0 is negative, I had told you in the beginning that positive 0 means inverse response. And if this 0 becomes negative, it will no longer be showing any kind of inverse response. We can say that we have, in this manner, applying the compensator which was making use of this k over here, and this k which is used in this compensator was designed making use of this inequality. This compensator is able to finally tame the inverse response. We will no longer be getting inverse response. The controller will no longer be getting confused. The human controller or any kind of PID controller or any kind of advanced controller will be able to tackle with all these things in a much easier and comfortable manner. In the next session, guys, we will be taking one practical example of the boiler, and we will see what is the inverse response and what is the practical way again to tame that kind of inverse response that we shall be seeing in the next session, taming inverse response. In case you have any queries for this session or the previous sessions, you can always contact me over number of methods which we have. WhatsApp group is there, Zoom session is there, you can call me on the phone and so on, or you can mail me. So in case you have any queries or any observations, you can always contact me. I hope you enjoyed this session. Thank you once again for being with me. Stay safe and enjoy learning.